Alrighty, welcome back to another video. And in this video, we are going to take an example Leetcode easy problem, and we're going to try and use algorithmic solving techniques in order to get the answer. So here we have a problem titled reverse bits. And basically, we're given a 32-bit unsigned integer, and we're asked to reverse the bits and return the number. So the first step, 190 reverse bits. The first step that we're going to do is we're going to say, so step one, determine what the problem is actually saying and asking us to find out, or asking us to return. To find out, I'll say find out / return. So looking at this problem, it's quite simple. Most of the time this might be just a restatement of what the problem initially says, but generally it's good practice just to kind of understand what's happening. So we're going to say this problem is asking us to reverse the bits of an integer and return the integer with the reversed bits with the reverse bits. So generally it's pretty simple to do this first step. Some harder questions might get a little bit more difficult, but generally speaking, this isn't too bad, and it is the first step. So let's make this full screen actually. There we go. Alright, so that's generally the first step. And then the second step, find some examples, or create some examples. Create some examples and attempt to solve them. So here it's just like, test cases. So we can see the first test case there in example 1. So let's just make a very easy test case. Let's say the example will be something like 0, 1, and then let's do, so we're gonna have, say, 28 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we have 30 characters, or 30 digits right now, and then we're going to say 1, 1. So now you have 32 binary numbers, and we're going to say the answer. It's pretty straightforward. 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And then when we reverse 0, 1, we're going to get 1, 0. So that's a good first test case to start off with. So we can see these other test cases here. I'm not going to write them out because it's a bit long, but now we want to try and, so the third step would be to try and find a pattern. Try and find a pattern to solving the problems. So basically we want to see how are these examples evaluated and how can we, I guess get to the solution. So if we take a look at Oracle's documentation here, we have bitwise and bit shift operators. So we have all these operators. We have the unary operator and we have the shifting operator. So the camera's in the way right now, so let's get that on there. So we can see the unsigned right shift operator. We're dealing with an unsigned integer here. So we're going to want to, if we're using a shift, we're going to want to use this shift, and we're also going to want to use the unsigned left shift operator, which is instead of 3 greater thans, it'll be 3 less thans. Okay? So we can either use that, we can use the unary bitwise operator, we can use AND, we can use XOR, or so what would be the best idea here? It might be a little bit tough to figure out, but let's think about it for a bit. So we see that in this example here, we can try and think of something. So we can say, okay, these 2 bits are put to the front. So how does that work? It's a little bit hard to say, or it's hard to think of in this example here if we're trying to reverse the bits, because then we think, there's no, arrays dot collection dot, sort, or reverse, excuse me, not sort, but reverse. But what if instead we could, for every 32 bit number, we could use a type of like array. Now this might be perhaps wrong, but we could try. It's all about trying. So we can say for each, we could say something like, what if the inputs binary digits are collected in an array. In an array. Then reversed. And printed. Or perhaps not printed. And constructed into a new binary number. So it's a general idea, at least to start off. For example, we could say right shift all, or we could say right shift by 1 32 times from the input. Now this right shifted off value, we want to AND with 1. So basically, for every integer, in the input, or every bit, for every bit in the input, we could right shift off the input, and we could add we could say add and, we could add and, so with bitwise and is something like this. I don't know, not particularly, but let's just say bitwise and. I'm not very good at drawing the and symbol. Bitwise and 1 to a array So basically what will happen is that first this bit here will be put into the input first, so it'll be here, at least in an array. Secondly, the second one will be put here, and then we will have a string representation of all of the bits. So the only problem now is how do we do that? How do we take, or how do we make this string array into a new number? What's up, Ma? Alright, so we can actually use kind of like a string builder here. So what I'm going to say is that, okay, instead of an array, how did I think about it? Let's think about, so the bitwise and one operator to a string builder object. Builder object. So once the string builder object looks like this, so once its length is 32, then we can parse that as an integer. We can parse the binary string as an integer. Now this may not be the best way of going about things, but this is the way that I thought of it first, and really as long as it is not too time complex and too complicated, then it won't be that bad. This will only be O one time because all these numbers will be of length 32. So the fourth step would be break into the smallest possible steps. So let's say steps. So step one. Step one is going to be make a string builder. Oh, we're going to be using Java. I never even said that. Java has a string builder class, which kind of works like Python string building, where if you have a Python string, you can simply append to the end of it. So make a string builder object, and then step two will be to, let's see, well, we want to right shift 32 times. Right shift 32 times. Oh, but before that, so say after appending bitwise and 1 with the current binary number. So basically this is going to make that string builder object. Add to string builder, or wait, append. So right here 2. We're going to say SB for short. Okay, and then step 3. Be convert the string builder to a string and parse as an integer. Step 4, there is no, I guess return return new integer. Okay. And then finally, step 5 will be to translate steps into code. So let's see if this particular procedure even works. So let's give it a shot. Let's turn that off. And now let's go to our coding screen. So the first step was to make a string builder object. So say string builder sb equals new string builder. And then we're going to say right shift, or sorry, the first step we have to do is we have to say we need to, what do we need to do? We can use do while loop here. Use a do while loop to right shift to to append bitwise and 1 and then right shift. So I'm going to say do while, and I'm going to use a I variable here, I less than 32. I'm going to say int I equals 0. So now what I'm going to say is I'm going to say we want to append bitwise 1 to sb. So I'm going to do that. So let's say sb.append. That will be n and 1. And then n should be right shifted by 1. I believe this is how you do it in Java. Right shift equals by 1 shift to the right. Okay, so now after this loop, we should have our string builder object as a containing all the bits in reverse order because they were appended to the string builder in this reverse order. So we're going to say the step. I need to put the step, so convert the string builder to a string and parse as an integer. So we're going to say string s equals sb.toString converts string builder to string, and then we're going to return the parsed int return s or integer dot parse int s. Let's try and use the example test case to see what happens. Oh, we need that to make sure that it only runs 32 times. Okay. Does that actually work? Oh my god, it does. Okay. So after a long confusion, we're able to complete the problem. So the main issue that I had here was I guess I just had to make it a long because of test cases like this. Because of the test case like this, because what happens is you get an integer which is, around 3.2 billion, which is above the actual limit for an integer in Java. So what needs to be done is instead you have to convert that integer to a long, or you have to parse it as a long which then you return as an integer. So the main problem is that since I guess this function needs an integer to be returned, you have to kind of convert it to long, and then you'll kind of get a wrong integer. So if we run this test case, I believe we'll get, oops, I believe we won't get the right integer. I could be wrong, but let's take a look. Okay, I guess we do. I just thought that we wouldn't be able to return an integer like that, which is outside of the normal range of an integer, but I guess you have to parse the string as a long first, and with a radix of 2, obviously in base 2, and then convert that to an integer. So overall, I hope you learned how to do a basic, easy Leetcode problem. I guess they're trying to trick me a little bit with this whole long thing, but overall very good stats as well. So that's always nice to see. And I'll be doing more of these videos, so I hope you enjoyed my struggles.